Bueno, pues vamos a empezar. Muchas gracias a todos los que ya estáis conectados y a los que iréis conectando ahora en estos primeros minutos. Mi nombre es Reyes Justribo y soy directora general de IAB Spain. Bienvenidos a un webinar en el que hoy vamos a tener una visión en profundidad de LIF, que sabéis que es la suite de herramientas que ha desarrollado IAB Europe y que incluye una serie de, pues eso, de herramientas para ayudar a reducir el impacto ambiental de las campañas de publicidad digital. Este es un webinar especialmente dedicado a agencias y publishers, pero evidentemente es para todos los que queráis incorporarlas a vuestras estrategias y campañas y que entendáis y veáis en profundidad cómo puede ayudaros a ser más sostenibles medioambientalmente, ¿no? Como decíamos. Vamos a ver dos herramientas que ya están activas, que ya hay al menos en España dos empresas que las están probando y a nivel europeo varias más, que son OpenGHG, que es la herramienta para estimar las emisiones de gas de efecto invernadero que emiten las campañas que hacemos, y luego Creatively, que es la herramienta que muestra cómo optimizar las creatividades, reduciendo el tamaño de las mismas, de los archivos, pero sin que sufra en absoluto la calidad visual. Para eso tenemos hoy a la mejor persona que podíamos tener para explicarnos y llevarnos a lo largo de las herramientas y entenderlas perfectamente, que es Dimitris Weiss. Él es Data Analyst y Sustainability Lead de IAB Europe. Es un placer tenerlo porque es la persona que ha dirigido y que ha liderado el desarrollo de estas herramientas y además está absolutamente involucrado. Él dirige también la Comisión de Sostenibilidad de IAB Europe y es la persona que, como digo, está involucrado desde el principio y que lo está llevando a cabo y lo está liderando. Ahora, si me permitís, perdón, cambio el inglés. Now in English, Dimitri, very welcome to this webinar. We are very happy that you are with us this morning, so you can take us through the two tools, how they work, so people can make questions and request clarity if there is anything that we are not addressing in the presentation. En cualquier caso, cualquier pregunta que tengáis, por favor, ponedla en el chat. Yo las iré recogiendo. No os preocupéis, si las queréis hacer en español no hay problema. Yo se las traduzco a Dimitri para que él pueda contestarlas en inglés. So now, Dimitri, the floor is yours. Go ahead. Thank you for being here.
Thank you for having me, Reyes, and it really is a pleasure to participate in this webinar because I know IAB Spain has a very active community on sustainability. We have already a few Spanish companies that use Leaf, and I'm really grateful for this opportunity to show you exactly what you can do with the tool, as well as take any questions with respect to how it works and how you can make the most use of it. So I'll be covering a few things today. First of all, I'll introduce you to the Leaf platform and the utilities in it. I'll talk about how the Global Media Sustainability Framework enables estimating emissions. As IB Europe, we have had a leading role with respect to the digital methodology. And then I'll talk about some use cases for open greenhouse gas across the ecosystem, focusing on publishers and agencies. Finally, I'll talk about how Creatively works and how it can help you demonstrate better compression practices. So first of all, on Leaf, Leaf has been in the works for quite some time. It was launched earlier this year. It effectively encapsulates a lot of the learnings of the IB Europe Sustainability Standards Committee into utilities that enable the ecosystem to access this work at a low barrier. It includes a couple of utilities at the moment, with one more currently in the works. creatively comes from our Sustainable Creatives Task Force, which looked at compression practices across the ecosystem in order to reduce the demand for networking resource during the delivery of ads. And Open Greenhouse Gas comes from our Methodology and Framework Working Group, which developed a proposal for the latest version of the Global Media Sustainability Framework that effectively provides standards for how to estimate the carbon footprint of digital ad campaigns. Now, the reason why we have produced LEAF is threefold. First of all, to help educate the market on the work of the Sustainability Standards Committee, and particularly to provide an easy way to use these outputs on a practical level in order to test these outputs and make sure that they are usable and all the guidance we need to apply this work is present. And finally, for feedback and improvement, it's very important for us to collect feedback from users of Leaf, both on the Leaf platform itself, but also, of course, on the underlying standards that Leaf is based on. We also update Leaf to match the latest version of all of our outputs at the Sustainability Standards Committee. So, for example, it has already been updated to match the latest version of the Global Media Sustainability Framework that was launched a couple of weeks ago in Cannes. These utilities are free to members, and they're also now accessible to non-members on a subscription basis. And for members of nationals like IAB Spain, there is a discounted fee as well. So now that I've talked briefly about LEAF and what it is, I'd like to talk a little bit about the Global Media Sustainability Framework because this really underpins a significant portion of LEAF. And Open Greenhouse Gas is effectively an application of the digital methodology in the Global Media Sustainability Framework. We've been working on the GMSF for quite some time. Since 2023, we're working with GARM in order to contribute to the first version. Before that, we had also analyzed the way different vendors estimate emissions from digital ads. We had surfaced insights from this analysis of current methodologies, found where the differences lie, why we're seeing so many different figures even on the same campaign, and also found the common denominators that we could effectively bake into a standard to be used by everyone. After Cannes of last year, when version 1 was launched, we have been working in close collaboration with AdNet who is now leading this initiative across 6 channels. And we have been leading the methodology development for the digital channel in particular. We have gone through a few rounds of feedback with the industry, both our members and the AdNet community. And now finally, this proposed methodology has been adopted into the GMSF. You will have heard perhaps of the digital data guidance, which is what we used as a term to refer to the calculations themselves, as well as the guidance required to apply the calculations and the default data that we provide in cases where data might be missing for users. Now, just to give you a bit of an understanding of how the methodology itself works, the first step was setting some concrete boundaries across the activities involved in a digital ad campaign to make sure we are all estimating the same types of activity. And we arrived at these 4 stages, starting with post-production storage. Post-production storage is about the storage of masters bundles that are produced at the end of the post-production process and effectively include all variants of different creatives, so different formats, different sizes, as well as localized versions, versions with or without legal language, etc. Selection is the most complicated stage. It is about the buying and selling of digital ad space. So here we have had to look at how exactly we model things like the programmatic supply chain, how we model end-to-end platforms, or you might have heard those referred to as walled gardens, because we don't have a lot of access into the internal operations, of course. And we have also had to model things like direct buy and build separate assumptions for each of those cases. Delivery is all about sending the ad to the user. So it's about the carbon footprint arising from that network transfer. And it's mostly focused on the payload of the ad itself and whether the user is on a fixed or a mobile connection. In delivery, we don't just account for networking infrastructure, we also account for content delivery networks because usually creatives will be cached at an edge node that is closer to the user's device. And then finally, consumption is all about the user device. It's about the resource consumption on mobiles, TVs, tablets, or PCs. And it's effectively a way to include the energy consumption that arises from the user device rendering the digital ad. Just to give you a bit of insight into how this process worked and how we arrived at the different numbers that come packaged in the GMSF now. Here we see our work on modeling servers. So the server model is a big part of how selection works, where we're accounting for different servers being activated, say in the programmatic supply chain. We had to consider a few different potential data sources from lifecycle assessments, which are effectively studies of different devices, such as in this case servers, across their life cycle. So from manufacturing of the hardware to the use phase and electricity consumption, all the way to end of life and how the hardware is disposed. On the bottom left there, you can see some of the options that we considered in terms of VM, virtual machine configurations, as well as a separate LCA that was done on the actual server itself, so the bare metal hardware. And that's not the full story. We have to combine that with a series of assumptions in order to adjust the figures we get from life cycle assessments to fit our purpose of estimating the footprint of activating digital ads. So the framework methodology working group had to consider what the most appropriate assumptions were, what the most appropriate LCA sources were to finally arrive at consensus with respect to which data points to use in the GMSF. And the problem this solves is, of course, each vendor or each company doing their own in-house estimation of digital ad emissions using different figures, and therefore these figures producing outcomes, emissions estimates that are incomparable because they're not equivalent to each other. This was a big problem, of course, because when you're looking to bias media spend based on these figures, if they're not comparable and they're not equivalent, you cannot effectively perform that optimization. Now, a big part of the GMSF methodology are what we call data levels. Data levels effectively facilitate a modular system for inputting data when you're using the GMSF. And we created data levels because we acknowledge that not all organizations will have the same data in their hands that they can use to understand the impact of digital ad campaigns. And in some cases, they won't have any data in their hands. And that is why the level 0 exists across most of these stages. Level 0 are the defaults that are included in the GMSF that you can use even if you have no data on a particular campaign. And these defaults are, of course, built in to the utility Open Greenhouse Gas that I'm going to show you in a few moments. Just a couple of notes on how the data levels work. First of all, we have made sure to apply the principle of conservativeness. That is to say, if you use better quality data, you will get a lower carbon footprint number than if you use more general and less specific data. So if you're using level 0 in this case, payload feeds into the delivery stage, your carbon emissions that you calculate will be higher than if you use level 3, which in this particular case relies on actually measuring the volume of data that is transferred when you're delivering ads. We also had a few other considerations, of course, when fleshing these data levels out. In this particular case, you'll see at the bottom there some overhead that is added on to level 0, level 1, and level 2. That accounts for payload beyond the creative assets, for example, players or JavaScript. And we are only applying it in this case to level 0, level 1, and level 2, because level 3 does not need that overhead because it relies on actual measurement of data transfer. So you'll see also in the notes column that we do provide guidance and explanations and examples for how each of these levels are supposed to work. And on the IB Europe website or through AdNet Zero, you can find the full GMSF document that explains exactly how the GMSF is supposed to be applied and includes examples of application as well. Beyond that, you can use the Leaf platform to play around with the GMSF yourself and see exactly what kind of figures result. Furthermore, just another thing on the GMSF, part of these default figures are not just the emission factors. So it's not just the figures that describe the carbon intensity of different activities. It's also things like defaults when it comes to how many users are on a fixed or a mobile connection in a campaign, or some figures that describe the intensity of servers in different regions. All of these are automatically baked into Open Greenhouse Gas and have been sourced by members of the Framework and Methodology Working Group in order to make the GMSF operational. And that's a pretty significant milestone for us because the previous version of the GMSF was, a great achievement. But we really wanted to make sure that in this version, you had everything you need in order to be able to apply it. So it's not just some kind of abstract standard that you might hand off to someone in engineering team to read through, but it's something you can use and effectively being able to transpose the GMSF into a utility like Open Greenhouse Gas also helps us validate that the GMSF is now usable and that the GMSF can now serve its original purpose. So just briefly giving you an overview of the data points required to apply the GMSF. These are combined with the data points that we provide as IB Europe through AdNet Zero in order for you to apply the GMSF. In storage, we care about the total master size, so the volume of data in that master's bundle that includes all the different variants, as well as the number of copies stored across different storage mediums. We have HDDs, SSDs, linear tape drives, as well as cloud storage. In selection, we care about the type of buy, direct, social, or programmatic. I would note here that we only consider the type of buying direct if there is no programmatic activation. So in cases where internal demand from the publisher ad server is competing with programmatic, but the pub ad server bid wins, that is still considered programmatic because we still have activation of the programmatic supply chain. We care about the format, display or video. This affects some calculations with respect to the volume of the programmatic supply chain. This is based on data that we have received from members that they have collected from their clients. We care, of course, about the geography, both the country of the user as well as the general region. That is because we assume some servers are located in the same country as the user and some servers are located in the broader region. For that figure on servers in the broader region, we have looked at publicly available data on server locations worldwide to figure out the right data points to use. We care about ads.txt lines because those are the main proxy that we have available at the minute to estimate the volume of the full programmatic supply chain. It's not a perfect proxy, and we are working to make data levels possible that rely on more granular information, but it is the common denominator across how different vendors estimate the impact of programmatic. And of course, we care about impressions. In delivery, it's mostly focused around payload and how many of your users that you're targeting are in a mobile or fixed location, and of course, where these users are. And then finally, under consumption, we have the location of the users, device type, so whether this is a mobile or a tablet or a PC or a TV, and then finally, average view time. So we use a time allocation here, and view time is the proxy to determine how many seconds of resource usage on the user device, we should account for. That is because we don't really know how much hardware consumption can be attributed to ad activations. There isn't enough research in this field yet, so we don't necessarily know how much power consumption from the modem on the device or the display on the device should be allocated to a particular ad. As a result, we revert back to a time allocation based on view time as a proxy. That being said, with this brief kind of overview of GMSF out of the way, we can now talk about open greenhouse gas, which is a tool that is designed to estimate greenhouse gas emissions from digital ad campaigns in compliance with the Global Media Sustainability Framework. It's a lean baseline application of the standard. That is to say, it's not as complicated as some of the work that vendors do to understand things like the programmatic supply chain. And it is intended to serve as a stepping stone so that more granular and complex applications can be developed by commercial actors based on the GMSF and effectively increases access to these standards. We wanted to make sure these standards are not just being developed in a working group and then being published and then being used by these vendors, but rather that every stakeholder in the ecosystem across the digital ad landscape in Europe is able to somehow use the GMSF in a very straightforward manner. So that is why we've developed Open Greenhouse Gas. And we hope that by making a tool available that's based on the GMSF at low cost, we'll be able to increase adoption and stimulate discussions on sustainability and integration of sustainability considerations within different organizations. Now, I'm going to show you Open Greenhouse Gas in just a second. I have prepared 7 different use cases for Open Greenhouse Gas just to illustrate how you can use the GMSF now that it's ready and operational. So these are 7 examples of questions that can be answered using GMSF and using Open Greenhouse Gas beyond just measuring the impact of a particular campaign. So these are specific questions that might arise internally that you can use Open Greenhouse Gas to answer. So first of all, let me just reload this just to show you how you sign in. So if you want to create an account, you use this form, and please let us know if you're a member of IB Europe because you do have free access. Otherwise, if you already have an account, you can just log in here. Once you're logged in, you select your utility, and here are the 7 use cases that I have prepared. So first of all, let's say you're an agency that needs to figure out which out of 3 potential options to use for a data storage policy for ad master bundles. So you want to figure out how many copies you should be storing across different storage mediums. You can use Open Greenhouse Gas to figure out the carbon footprint implications of these different options by inputting the data describing the 3 options under storage and then picking the option with the lowest emissions. For this example, we're going to assume a standard master bundle size for all 3 cases, and I'll show you here what exactly that looks like in practice. So we've assumed that the master bundle here is 10 gigabytes. We could make really any assumption as long as it's the same between the 3 policies. And we have policy number 1 with 2 copies on SSD and 1 copy on HDD. We have 0 copies on linear tape and 1 copy on the cloud. On the right-hand side there, you can see that that will be equivalent to about 2.25 kilograms of CO2 equivalent. And then policy number 2 that features 1 copy on SSDs, 1 copy on linear tape, 3 copies on the cloud is 0.97 kilograms, the most efficient one out of the 3. And then finally, policy number 3, we have 0 SSD copies, 2 HDD copies, 2 copies on linear tape, and 2 copies on the cloud. That's about 3.7 kilograms of CO2e. Just to show you how this works, we can now define another policy, let's say policy number 4, We're going to keep the payload size the same at 10 gigabytes. And let's make this a very carbon intensive policy. So we would have 4 copies on SSD, maybe 2 on hard drive, and then we would have maybe 1 here and 4 on cloud. We add this to the campaign. And you should see this appear at the bottom here with about 5 kilograms of CO2 equivalent. So if you're an agency and you want to figure out what your data storage policy should be, and you want to take carbon footprint in consideration when doing that, you can now do that in a way that is compliant with the Global Media Sustainability Framework through Open Greenhouse Gas. The next use case, let me just put this in full screen for you, is publisher ads.txt. And these are quite important when it comes to digital ads and emissions estimation, exactly because they're used as a proxy by most of the vendors. So let's say you're a publisher that is evaluating its ads.txt file, looking to optimize it, maybe perhaps shorten it a little bit, and you want to know what the implications of a potential reduction in lines is when it comes to third-party evaluations of the carbon footprint of your inventory. You can simply input the number of lines before and after this optimization under the selection stage and observe the difference in the estimated carbon footprint. So I'll just go back to campaigns here, select our use case number 2 that has this data already in there. And you'll see that we have pre-optimization 500 lines, post-optimization 350. And you can observe in the right what difference that makes for 10,000 impressions when it comes to total emissions. By the way, you'll notice that here we also have use phase and embodied emissions. Use phase refers to the electricity consumption, whereas embodied emissions refers to manufacturing and end of life. Back to our use cases, number 3 is about reducing estimated emissions by using targeting on fixed connections rather than mobile connections. So trying to reach users that are connected through Ethernet, let's say, rather than 4G or 5G. This is relevant, let's say, if you're a media planner at an agency that is looking to account for carbon emissions and reduce that number for a client. So we'll use the GMSF default data for the payload, so the actual size of the ad, and we'll input manually some data describing how many users are in fixed and mobile connections. We'll use 2 scenarios, and that is how we're going to see what the difference in carbon footprint would be. So I'm just going to load our use case number 3 here, go to delivery, and here we see pre-optimization. I used the defaults that we provide, so 74% on fixed and 25% on mobile. If we shift that a little bit to 85% on fixed and 15% on mobile, you can see that we cut emissions by a little bit per 1,000 impressions. By the way, all of these calculations I have made sure work with a location of Spain. So you'll see that these examples are applicable for IAB Spain members. Use case 4 is about creative guidelines. So let's say you're a publisher that operates your own ad server and you have rules for the creatives uploaded to your server. You're looking to determine the reduction in carbon footprint that arises from lowering the maximum file size that you allow. You can input the current maximum data under delivery as well as the new maximum under delivery, and therefore see what the difference in estimated carbon footprint will be. Just note that here we're talking about static that sometimes isn't transcoded after upload to the ad server. For video creatives, oftentimes they are transcoded, and therefore we should be more careful about the type of reduction claims that are made around those. So we'll go back to campaigns, load up use case number 4. And here we should see the difference just in a second, confirming it is use case number 4. Yes. Looks like we are bugging out a little bit, but it should load in just a second here. There you go. So we have previous guidelines and new guidelines. You'll see that the payload max has been changed from 35 kilobytes to 25 kilobytes, and therefore we observe a slight decrease in total emissions. This is information that can help you when you're setting your rules for your ad server as a publisher, and you want to set some rules that will lead to a reduced carbon footprint from activations on your properties. Number 5 is about direct buy. So if you are a publisher that wants to evaluate the carbon implications of direct sold inventory against inventory sold programmatically to optimize something like throttling of header bidding, you can use the GMSF and Open Greenhouse Gas for that as well. Specifically on Open Greenhouse Gas, we have a slider that allows you to select when you are buying or selling programmatically. And that slider is what you have to change right here if you want to account for direct sold or bought inventory. So you see at the bottom there, there's quite a substantial difference between programmatic and direct. That is because of the number of servers that are assumed to be activated during direct transactions as opposed to programmatic buying and selling. Just keep in mind that we only call these transactions direct if there is no activation of the programmatic supply chain. So here you can evaluate exactly what the implications say for your estimated emissions from all ad activity are if you put aside some inventory and dedicate it purely for direct buy or direct selling in this case. Use case number 6 is about social versus programmatic. So if you're a media planner that needs to evaluate the difference in estimated emissions between buying web video and social video, again, under selection, we'll use an average ads.txt line count from previous campaigns. I think in the specific example, it's about 500 lines. And then we're also going to select the social slider that allows us to account for social buy. So we go back to use case number 7, and here it will take a second for us to load the campaign. And we have a comparison again between programmatic and social. The ads.txt lines, again, are assumed to be 500. And the way social and any kind of end-to-end platform activity works under the GMSF is that it has specific assumptions built for it. And these assumptions were built in consultation with a lot of our members that operate these platforms. And then for the final example, reducing estimated emissions by targeting users on mobiles rather than PCs, because we have these different device types that come with different figures on estimated carbon footprint, shifting activations between them does result in a difference with respect to the estimated carbon footprint for the campaign. So we're going to use the GMSF default data for view time because we don't know what the actual view time of this campaign is. And we're going to select 2 options. In one case, we're going to have PC as a device type, and the other case mobile, and we'll effectively get benchmarks for the carbon footprint of activating on those different types. And we can do the same for any other device type, really. So I'm going to go back to our campaigns, load 7. Wait a second for it to load. And now that it has loaded, you can see that we have the mobile with a default loading time of 3 seconds, delivering about 0.2 kilograms of CO2. And the PC alternative per 1,000 impressions is a bit higher at 0.23 kilograms of CO2. You'll also notice that the energy consumption for mobiles is much lower. However, the embodied emissions are higher. So the emissions associated with the manufacturing and the disposal of that hardware. And that rounds out these 7 use cases for how you can use open greenhouse gas and the underlying GMSF standard. Beyond these, you can, of course, use open greenhouse gas for its intended purpose of estimating the carbon footprint of a full campaign. And by inputting the relevant data under storage, selection, delivery, and consumption, you can get a full view of exactly what kind of emissions are estimated to be associated with that particular campaign. Beyond that, you can also answer questions like these that might arise and have a very useful tool to input data into your decision making from a carbon footprint perspective. Now let's talk briefly about creatively. This will be a bit technical at stages, but I'll try to go through the more technical components faster and focus really on what creatively is meant to do. So when we're looking at the GMSF and the activities included in the GMSF, under the delivery stage, we can identify that lower payload, so lower add file sizes, are a decarbonization lever in the GMSF. So what that means is by lowering your payload, you can reduce emissions as estimated by the GMSF. Better compression also means improvements across cost, latency, and performance. As you can see at the bottom, reduced file size reduces storage cost, and by reducing latency, it improves the user experience and tends to deliver better performance. There is a lot of work that's been done to back this up at both an academic level and from within the industry. Now, briefly on how image file compression works, it leverages things like the fact that human perception is less sensitive to averaging out color than it is to brightness. It also leverages very interesting mathematics that effectively represent the same image, but in a much more data efficient way, utilizing things like Huffman coding and quantization tables. These tend to come packaged with any kind of standard that is being used for image compression. So there'll be a different way that, say, JPEG works to AVIF or WebP. And if you use a standard quality setting, say quality of 60, there's going to be a standard set of math applied that takes the original image and cuts the file size while also reducing the quality to some extent. Now, the example above draws from the JPEG codec, which leverages these specific assumptions and this specific math, but it's a similar kind of story with all of the other formats. And here you can see some of the details on how these other formats work. The most important line is the one at the bottom there. JPEG tends to offer the lowest compression ratio. WebP offers a compression ratio that is usually higher, and then AVIF usually offers the highest compression ratio. However, there is a trade-off here because a format like AVIF, or to be very specific, a codec like AVIF also requires more computational resource to both compress and decompress. So you'll see that the typical CPU load also scales with the compression ratio, and the compression ratio is what we use to refer to the amount by which we have lowered the file size of the image. One more thing here, not all of these codecs are supported in all environments, so sometimes you do have to revert to JPEG, perhaps as a fallback mechanism for compatibility purposes. Now, the question here is not just how we compress images, but also how we measure how much quality was lost. And in the digital advertising context, perceptible losses in quality are quite important, and rightfully so, brands want to avoid that. As a result, in Creatively, we have baked in a couple of methods to make sure that we are not losing too much quality from these images as we show users how they can be compressed further to reduce the carbon footprint without harming the creative itself. One of these ways is the structural similarity index measure. This was developed by researchers back in 2004 that measures the difference between two images pre and post compression. Another one is Butterogly, It was developed by Google. And on the right, you can see a very interesting heat map as Badarogli guesses where there are perceivable differences in quality as a result of the compression. The only issue with Badarogli is it's quite computationally intensive, and therefore creatively OnLeaf uses SSIM, which is the structural similarity index measure. So here's how creatively really works. You upload a master file, which is a high quality, relatively uncompressed, lossless file, such as a PNG, and then you input some targets. Here we have an example when you're targeting a specific SSIM. We find that with an SSIM of 0.95 to 0.97, you achieve pretty good results that reduce file size and are not perceivable by the human eye. And the reason why we have come up with these values as the default when you're using Creatively is because there's been research done to understand where exactly humans start seeing a difference when using SSIM. So Creatively will work to compress the image again and again, and then find the optimal transcode for the targets that you have set, and will effectively illustrate how much you can push the image in terms of compression while maintaining quality, because that's really important for our use case. And here, what is why it's better than current approaches. So say you have a 230 kilobyte, relatively uncompressed master file. You could use something like the lean specifications from IB Tech Lab, but you'll find that the limits there are quite high because those specifications also came out some time ago, and there have been a few advancements with respect to file compression, and typical sizes today are a bit lower than that. You can use a heuristic, which is pretty common as an option. You'll see that a quality setting of 75 is often used by a lot of ad servers. And here you'll get a JPEG weighing about 27.8 kilobytes. Or you can use Creatively with an SSIM of 0.95, which is a default, and you'll get a JPEG that is a bit higher in file size, but is much closer in quality to the original. So in this particular example, if you had just used a quality setting heuristic, like quality setting is equal to 75, you would have gotten a JPEG that has reduced file size, but is also overly compressed. And therefore, there is a perceivable difference in quality. As you can see with SSIM being 0.91, your users will be able to tell that this creative has been compressed and won't look as good as the master file. Whereas if you use Creatively, you're ensuring that it does actually match the master file with respect to perceivable quality. So a few other reasons why it's better than current approaches here. It extracts as much compression ratio as possible from the process. So it effectively leaves nothing on the table, as some heuristics-based approaches might. It also protects against artifacts and quality loss. That's pretty important for advertisers. And it can also optimize for different targets. So either give you the best creative based on the visual metric, or it can give you the best creative that falls below a given file size limit. And on the right there, you can see that calculation done with a file size limit of 50 kilobytes. So it tells you what quality setting to use and actually gives you the image itself just under 50 kilobytes across JPEG, WebP, and AVIF formats. It also optimizes assets across all three formats all the time, which gives users a clear understanding of which formats are more efficient, and also provides a JPEG for compatibility purposes. And also it simplifies the overall problem of compression down to a single input, which is the target of the psychovisual metric. The psychovisual metric in this case is SSIM. It's not perfect, of course, because metrics such as SSIM, they measure distance of the compressed image from the master, and therefore they cannot be used as a standard target all the time. What that means is that you do actually have to check to see that image is good enough in terms of visual quality, but it gives you a great way to arrive at the final creative you should use in a simple and straightforward manner. And Reyes, I believe we're about at 45 minutes, so I'm going to wrap up here and happy to take any questions.
Yeah, thanks a lot, Dimitri. I think it was very, very comprehensive, very detailed, and really understandable for anyone that has been in the call. Let me see, because here, yeah, there is a question by David Lao. Thank you for that, David.
Mhm.
And he is asking if creatively store the images that are uploaded to the platform and
Mhm.
or the images that are optimized.
So creatively wipes the images on a rolling basis. I believe it's a 24-hour period where these are wiped from the server. What we do collect is some metadata, so specifically the file size before and after compression, so we can improve creatively potentially in the future by doing some modeling around this data. This would allow us to deliver the best file size and the best quality setting options to the user faster rather than having to do it manually by iterating over the options with a binary search algorithm each time. So we're not actually keeping the creative itself, but we are collecting some information from the use of the tool to improve it as more users get on board.
Thank you, Dimitri. Um, we have other questions that has come even also by mail, and there is a question about if there are any limits on the size or number of files that can be optimized per session.
No, I don't believe there are any limits. We have some backoffs in place to prevent um, abuse of the utilities, but these should be, completely fine for any kind of human. They're mostly targeted towards bots. So you can upload as many assets as you want. Right now, it's display assets only. And in the future, we'll be releasing a utility catered to video assets as well. We have actually just wrapped up the backend code for that, and we aim to get something out by September.
Yeah, because that was going to be my next question about the different file formats that creatively support, and you have already responded. So you are looking forward for September release of the video one?
Yes, and I'll explain how it works as well, the video one,
Yeah,
because we do have it mapped out. There's also a question I see on GIF or GIF formats.
yeah.
Naming conventions vary here. It does not currently support them. We can, however, support them and add support in the future if that is something users would find useful. So if you want to shoot me a quick email, my email is on the deck there, and we can have a conversation about the kind of context in which this would be useful for you. It's also kind of different if they're animated or not, but we do have a local version working that works with animations too. So if that is something that users would find useful, we can of course upload it to the version that is made available on Leaf. And then with respect to the video utility, we are putting out a utility that loads VAST and runs a series of checks on how the tag works, specifically to see whether best practices are implemented with respect to sustainability and minimizing data waste. So we'll be running tests like moving the placement in and out of view and seeing whether the data transfer stops. We'll be looking at things like the buffer and making sure that these are optimized so that we minimize the amount of resource consumption on networking infrastructure.
Okay, thank you so much for that. I have the last one, and people are wondering if Leaf can be integrated with other campaign management or data analytic platforms. Do you have any insight about that?
Yes, we are thinking about exposing an API so that you can integrate with Leaf on your side. We don't have any working integrations directly with different platforms. But the idea here is that if we do expose an API, and again, please do reach out if that would be useful, because our development of Leaf relies on this feedback. You could potentially ingest the data from these platforms on the client side, and then also connect with the Leaf API to estimate emissions on a continuous basis or in a post-campaign report.
Okay, thank you. So I think we don't have any more questions. Anyway, if anyone in this webinar or afterwards have any question or doubt, we will send that to you. And thank you so much for today, for your time. I was telling the people attending the webinar that you were the best one to explain that and to lead us through all the this path of this package of tools, and you have honored what I say at the beginning. Thank you for that, and thank you for giving us all these answers and all this information. Y muchas gracias a todos por estar hoy con nosotros. Lo dicho, cualquier pregunta, cualquier duda, nos la comentáis, se la redirigiremos a Dimitri y seguimos apoyando y trabajando en que tengamos una industria mejor desde un punto de vista de sostenibilidad ambiental. Muchas gracias a todos. Thank you so much, Dimitri. Take care.
Thank you very much, everyone.
Bye.
Bye-bye.